Welcome back. This is lesson 9.3 journal, Analyzing Relationships. I will be able to use an input-output table to create an equation for a linear relationship. So vocabulary for this lesson, we have independent variable. Remember, this is the one that's in charge of the situation. It does its own thing. It's going to happen no matter what, or you're in control of it. The dependent variable is the variable that changes because of the independent relationship. So it's what happened because the other one happened. Rate of change is how much the dependent variable changes for every time the independent variable changes. Starting point is where the dependent variable starts in a situation, and a linear relationship has a constant rate of change and a starting point. So the table shows the amount of time Jonah spent working on and the amount of money he earned. Write an equation to represent the relationship between time spent working and amount of money earned. Okay, in this, which is in control? Do the hours you work control the money, or does the money control the hours you work? In this case, hours worked controls the amount of money. So hours worked is our independent variable. The dependent variable in this relationship, the dependent variable would be money earned. Because he worked, he earned money. Now, what would be our starting point? After 1 hour, he earns $14. After 2 hours, $28. But what would it have been if it was 0? So every time this goes up, let's look at the pattern here. Every time this goes up, 1 hour. This goes up, well, 14 to 28, that goes up 14. Here, as this goes up 1, this goes up 14. As this goes up, this went up 2 hours. This one increased by 28. Well, 2 times 14 is 28. So we can see that same rate of every time this increases 1. So in other words, for every hour, you can see that this goes up 14. So what if I went backwards? So this would be back 1 would minus 14. Back 1 would minus 14. So 0 is just back 1 from 1. So if I'm going back 1, that means I've got to go back 14 here. If I go back 14 from 14, that would be 0. Which in this case makes sense. If you haven't worked any hours, you probably aren't earning any money if it's an hourly job. So the starting point here would be $0. When he's worked 0 hours, he has earned $0. So what does this mean? Let's write that out. When he works 0 hours, he starts with $0. Alright, the rate of change. As my independent variable has gone up 1, this has gone up 14. So how much is the dependent variable changing every time the independent variable changes? 14. So 14 plus 14, it's increasing. So what does this mean? Plus 14 for every hour. Well, in this situation, that's the money earned. Well, that's how much he gets paid every hour. So that's his rate of pay. He gets paid $14 per hour he works. So we got this from the table. So now we're going to write an equation for the relationship. Okay, it's always output equals. So how do they figure out his paycheck? Money earned, I guess it's capital M, money earned equals. What does his money start with? 0. So starting point of 0. Now then, does it increase or decrease? It's increasing. How much for every hour? $14 times for every hour. We could also write this as M equals 14H. Why can I do that? Because it's not absolutely necessary to write plus 0. However, I really like you doing it on these so you can always see where it would start. Now that we've got an equation, how much money could Jonah earn if he works for 8 hours? Or what about 26 hours? Well, we can use our equation to figure that out. So I'm going to take money and I'm going to times 14 by here first, 8. And 14 times 8 is 112. So he could earn $112 for 8 hours of work. 26, same idea. Except this time we're going to plug in 26 for 14. You can use your calculator for it. So 14 times 26 gives us a total of $364. So you can see how if you can find the relationship that ties these together, you can figure out for any amount, and that's the point of an equation. This works for any amount you want to test out. You could even put decimals or fractions in here. If he worked half of an hour, how much money would he earn? Well, 1/2 times 7, or sorry, 1/2 times 14 would be 7. He would earn $7. So this isn't just to work for whole numbers. It works for any number you're to plug in there. Let's try this next one. It says, the table shows the relationship between the total cost of an app compared to how many months Misty has owned it. So independent variable in this situation. She chooses to own the app, and because she owns the app, it's going to cost her money. So independent here would be the months owned. And cost in dollars. So total cost would be the dependent. So looking at this, we want to figure out a starting point. Remember, starting point is when the independent variable is 0. So let's see if we can follow a pattern here and figure out what the starting point would be. So after 1 month, so that's gaining 1, how much did it change here? 15 to 18, that went up $3. Here, another month of 1, another change of $3. So this is going up $3 for every month she owns it. Let's see if that follows here. This one jumps 3 months. 21 to 30, that jumps $9. Well, 9 divided by 3 is still 3 for every 1 month. So that pattern is showing up. Now to go backwards, if I go back 1 month, I drop $3. Go back 1 month, drop $3. To go from 1 to 0, that's going back 1 month. So that means I've got to drop $3 to figure out this amount. So that would be 12. So the starting point in this situation is $12. Okay, what does it mean for the context though? Cool, we found the starting point. We're talking about how many months she's owned an app. Well, if she's on it for 0 months and it's already cost her $12, that's probably the cost of the app itself. So the app costs $12 to buy it. So you had to pay for the app to begin with, then it looks like she's getting charged every month for owning it. So the rate of change. My dependent variable is changing how much for every 1 time my independent variable changes. So this is changing $3 for every 1 month. $3 for every 1 month. it's increasing by $3 per month. So in this situation, what does that probably mean? Probably means there's a subscription fee for using the app every month. So there is a $3 fee per month to use the app. So write an equation for this relationship. Output equals cost can be found by doing what? Where does our cost start? Well, just to download the app, it's going to cost $12. So there's a starting point. Now, it doesn't just cost $12. After that, they add, because it's going up, how much per month? Adding $3 for every month she owns it. There's your equation. So how much will the app cost her to have for 1 year? So 1 year is 12 months. So I'm going to plug in cost equals $12 plus $3 for the 12 months she's going to own it. 3 times 12 is 36. And 12 plus 36, her total cost is going to be $48. Okay, a similar app costs $65 but does not require a monthly fee. When will Misty's app become more expensive than the similar app? Okay, this is where we can play with numbers until we find something that's bigger than 65, or we can use a table to help us see the cost. So we know it's going to be at 12 months already. So what I'm going to do is I'm going to keep going with the table. So I'm just going to make it easy. Months and cost. So we know at 12 months it's going to cost $48. Well, we can keep using that pattern till I get to 65. So at 13 months, $3 more would be 51. This might take me a while to get to 65. So maybe I can play around with some other numbers. If this is growing 3, what if we jump to 16 and see where that is? Let's try 16. I'm going to plug that in my equation. So cost equals $12 plus $3 times 16. Well, 3 times 16 is 48 plus 12. 48 plus 12 is 60. So it's going to cost $60. Is that still over 65? Not yet, but I'm close. So from here, 17 would be 63 because that's $3 more because I only moved up 1 month. Pretty dang close now, so let's try the next one. So 18 would now be $3 more, 66. You see how you can play with it? The table can be helpful if you want to jump by ones, but if you want to jump more, you can use the equation to play around with it and get bigger answers. So right here, I see that I've crossed the $65 limit. So when will Misty's app become more expensive than the similar app? When it reaches $66. So after 18 months, and from then forward, because she's still going to be paying $3 after that, after 18 months, her app will be more expensive than $65. Okay, rate yourself on this concept, 0, 1, 2, 3, or 4. Take a picture and turn it in on Google Classroom.